Hi everyone. So Barat, Alberto, Nils, and me, Clément, will present her project, Dispatchable Indoor Location for Wireless Service. So to find the goal of our project, we can regard the requirement from the FCC for indoor location. So the FCC requires a wireless service provider to find a customer location within a building when they make an emergency call. And for that, they require two important parameters. The first one is to provide the location information within 30 seconds from the beginning of the call to the location appears in a screen. And the second parameter is the accuracy of the location should be within 50 meters of the caller's location. So in order to solve this problem, we approach this problem with two solutions, two technologies. So the first one is the Wi-Fi technology using access point provided by our school IIT IT Management. And the second solution is the Bluetooth using iBeacons. So during our project, we used different modules. So three of them were directly available to us. The NG911 test bed provided by our school in the lab in the IIT tower, and the Wi-Fi infrastructure and management system provided by our school by the IIT IT Management. And in the second point, we built different devices, so 4 devices. The Bluetooth devices, we built 2 phone applications, one for the Wi-Fi and one for the Bluetooth. We built also 2 servers that provide the location server, so same, one for the Bluetooth and one for the Wi-Fi. And finally, we built a Bluetooth device management server. So you can see on those pictures the Bluetooth device. So the picture on the right shows just the Bluetooth device, and on the left you can see the Bluetooth device that we already deployed in some IIT buildings, and that we will deploy in the summer or soon. So now let's take a look at the first solution, the Wi-Fi. So as I said, we use different modules for our project, for it to work. So the Wi-Fi access points and the management system provided by our school, by the IT management. After that, we use the location algorithm server made by Barat and managed by Nils that we will explain in few slides. And finally, we used an Android application made by our predecessors. So now let's take a look at the call flow of the Wi-Fi. So it's pretty simple. When someone dials 911, the phone application will turn on the Wi-Fi and then probes the network. After that, the MAC address of the phone will be sent to the location server, and the location server will contact the server management, the database, and the access point, and will locate the access point of the database, which sends the MAC address of the phone, and send back this list of access points to the location server. So after that, through an algorithm, the algorithm will find the closest access point of the user and will send back this location of the closest access point, of the access point closest to the user of the phone, to the phone. So after the phone will send back this information. Into a SIP invite in the NG911 testbed, and finally the NG911 testbed will route this information to the closer operator system, and finally the location, so the address, the floor, and the room will appear on the operator system, on the emergency operator system. So now let's take a look closer at the algorithms by NERS.
Okay, so for the location server, we needed algorithms to actually figure out where your location was, so which is what I was working on in this case. So last semester, we collected about 400 data points by testing, where we wrote down the physical location of the person manually, and then we just collected the Wi-Fi data around it. And what? Oh. Okay. So we collected it. So we just have a data set of around 400 points where we know where we manually wrote down your actual location, and then all the data surrounding it. And then we ran our algorithms against this data set and tried to improve them. So the first thing we did was a grading scale to actually judge our algorithms, where we said D was you missed everything, C, you got the correct building, but you missed the floor in the room. B, you got up to you got the correct floor of the correct building, but not the room itself. And then A, you got the room as well. And then we considered a success to be an A or a B, so as long as it gets the correct floor, and then failure to be C or D. So the algorithms were maximum signal, where out of all the signal strengths that were returned by the access points, or out of all the signal strengths for the access points, which one was the highest? And whichever access point gave us the highest signal, we just said that we figured that would be the closest access point to your location, which gives us an 82% success rate, defined as getting to the correct floor. And so then we had the problem of if you're on floor 3 and on floor 2, right underneath you, on floor 2 at the ceiling of it, then you have an access point that's physically close, extremely close to you. But if you return that access point, then we'll send you to floor 2 because it's physically closest. But obviously, that's not where we actually want to send the police operator. We want to send them to floor 3 where they would actually reach you. So we were trying. So average signal and most responses try to filter out. It first tries to decide the correct floor, and then it tries to decide the correct AP only within the scope of that floor. And so average signal just takes the average out of all signals by floor, and whichever floor has the highest signal, then we'll run maximum signal only within the scope of that floor. And then most responses is whichever floor gives us the most number of access points respond to the phone. That's the floor you're most likely on, and then we run maximum signal to get the AP on that floor. And so most responses gives us 90% success rate, and then average signal surprisingly gives a 60% success rate. It's basically, it ruins us. So these are the grades more subdivided. Notably, almost all of these successes are within the Bs, where it's defined as floors. A's only get about 20% on most responses and maximum signal. For average, it drops in B. It drops at getting the correct floor, and then it drops in getting the correct room as well. Because obviously, if it misses the floor, then if it returns floor 2, then it'll pick an AP on floor 2. And if you were on floor 3, then obviously it will miss. But most responses is a direct upgrade in terms of getting the correct floor, and doesn't affect the A chain or getting the correct room. The problem with the A grade is that it only really makes sense if APs were one-to-one with the rooms. But that's obviously not true. The APs are shown in the green circles. You have one AP for many rooms. So so when the algorithm returns an AP and the location of that AP within a room, then it'll return floor. It'll return this room. But if you're sitting over here, the AP covers that, and it is the closest to your location, but it'll fail. The algorithm will get a B grade because it misses the exact room. So we, in order to make that more granular, we divided the rooms into 4 quarters, and then we just said that AP3 is in quarter 1, and this room is in quarter 1. So if you're in, so if the test location is in this room and it returns AP3, it's so you're in the same quarter, then you get B+, where it's defined as correct quarter of the, you get the correct quarter of the floor. So now we're just testing that we didn't send you to the opposite corner of the floor that we wanted. And so then a B- is defined as basically the diagonal. So if you're in quarter 1, it doesn't return quarter 4. And then a B is just, it's the correct half of the floor. So it's this side or this side. So basically it's not the diagonal. So we just get a more granular view of where we're locating you within the floor. And it turns out that almost all of it is, like the success rate has now been changed to A's and B pluses only, so we ignore B and B minus. And the success rate doesn't change significantly. It turns out that every time we do give you a location on the correct floor, we're actually getting it almost always within the same quarter of the correct floor. And so we're well within the range of the 50 feet requirement for the FCC. So for the future, we'll collect more test data, improve the algorithms, and then what we want to do is we want to compare the results of Wi-Fi to the results of Bluetooth, which we would do once Bluetooth is actually finished, and we have test data on that. And so now Brad and Alberto will explain the Bluetooth implementation.
Thank you, Neil. All right. So our second approach was the Bluetooth approach, for which we required 4 modules. The Bluetooth devices, which we built with a little bit of IoT engineering, a Bluetooth management system to manage the devices, a location server to basically feed the location, and we built an Android application for the phone. The structure of how the call flow works is extremely similar to how it works on the Wi-Fi side, except here we have beacons. So when someone dials 911, the phone scans the environment for these beacons, gets their unique identifier information, and sends that to our location server. The location server then runs an algorithm and returns returns the location information back to the phone. The phone then embeds that information into a SIP invite and forwards it down to the appropriate PSAP operator. It's very similar to how the Wi-Fi system works, except with a few changes. This is basically that. And Alberto will explain how the phone application works.
Thank you, Bharat. Well, from the application point of view, first, we are placed in an environment where we have all the sensors, Bluetooth sensors deployed. These sensors are sending signals with their identifiers, and then the Android application, when we turn on the Android application, the user will be asked to turn on the Bluetooth, and then the Bluetooth controller will start ranking all the beacons around the user. The information that this application will gather is basically identifier and power strength from these beacons. And this information after that, after pressing call 911, will be sent as HTTP GET to the server. Then the server will receive this information, will query to the database what's the location of the closest beacon of the user to the user. and then this information will be sent back to the Android application, which will embed this indoor location into an XML Flow and set it in the zip invite to the emergency SINET. Well, here we have an example of the XML Flow with the indoor location. We can see the floor of the user and room number. In this case, we are in the 9th floor in the room 32. And after this Flow is sent in the zip invite, the call dispatcher in the PSAP will receive this XML, and with the zip call taker application, the indoor location will be parsed, and we will receive this this room number and this location. And now Bharat will explain something about our approach and our results.
Thank you. So our results for our Bluetooth project this semester are we were successfully able to make calls using the Bluetooth technology, which is great. We have begun deployment of 80 beacons in our IIT building here, and we will successfully have a testing environment by the end of summer. And we have created a management system that would send us emails as a notification if something is wrong in the testing environment. That is, if a device goes down or anything like that, we will know immediately and we can fix the problem. Our future for the future, we are looking to collect test data in our testing environment and create algorithms that are more accurate. We want to deploy more beacons and cover the whole of IIT campus, and we want to improve our management systems, our management system for the Bluetooth devices, and we also want to extend the capabilities of our current database so we can do more functions and a lot more things. And we have a demo for you, so. That right there is the call taker.
Right now we are connecting through TeamViewer to the call taker, so we are seeing what the call taker would see in real time.
Is this in real time?
Yeah, it's in real time.
Okay, so this actually is in the tower?
It's the tower.
Okay, so you remoted into the tower?
Yep.
And on the other side we have
This is happening in live.
Yep. And Alberto will simulate a 911 call now. Yeah.
The screen of the. Can you restart the streaming?
I'm sorry.
Here? Yeah. Okay. Yeah. This is my phone right now. Oops, we don't see it now.
I apologize. We should have practiced this, but
Yeah,
this is
the board now. Okay, cool. So, right now I will execute the call, and now I'm gathering information of the beacons around the cell phone, and I'm calling. Another call dispatcher should receive.
a call. Oh, come on.
Oh, someone is using it. It's you? Or?
No, John. Joe's. Yeah. No?
Okay,
Did you register?
Yes, we did.
let's try. I'm
So
registered.
can you release the call?
I was watching you test calling before you went up there.
We made like 20 test calls and it worked. No, it just doesn't work.
Yeah, well,
It's camera shy, that's all.
What? No. Joe, what did you say?
Re-register.
Re-register.
yeah, we are.
Re-register.
Ah, okay. So I put an airplane.
Yeah. Turn on.
I'm sorry about that. Airplane mode.
Yep.
Now I should register. Yeah, that's my registration. To destinate. Now I open the Android app and execute the call. Now hopefully it will work. Yeah, that's good. There we have the call.
All right. Let me switch this
Can you
over here.
accept that?
Yep. And
Yeah.
right here you can see, right there, you can see that we're in the Alumni Lounge in 3241 South Federal Street. And this is live. It's right there by our poster. There's the Bluetooth beacon's right there, and what you're seeing here is actually live. All this information is live. As a matter of fact, why don't you go?
I can go to the next room and we can do a try. Okay. Can you release?
Yeah. Joe, can you release? Thank you. It's just really hard to do it like that. So, full disclosure, we've deployed another beacon in a secret room here. I have no idea where. Alberto did all the tricks, so. And he's going to make another call, and whichever room he's in, the call will come in and.
Point out that you had to put that into the CAD.
Yeah, we had to put it inside our database. So we have identifiers for each and every Bluetooth beacon, and each identifier has a physical location built into it. So when the calls come in, those physical locations actually come through, and there you go. And now Alberto is still in Alumni Lounge. The other beacon must have died.
Well, it's good that it has so much range.
Yeah. But from what I gathered, I assumed it was supposed to have happened in some other room, but for some reason it just didn't work for today. Again, camera shy and all that.
What you can do, you can cover this one.
It's close the room. I can't enter. We got the beacon inside. I don't know. Someone have the key.
So
It's easier to disconnect this one. The other one is surgery.
Yeah, but this would be cheap.
No, but
It's not cheating. It's just the opposite.
But that's interesting because you were fairly far away from this one, right? And it's still, that was the hottest one because apparently that one is far enough away. Is it at the other end of that room?
It's on the line. I can get into all the nearest I can get. Right here.
no.
Because it has its own identifier.
You have to move it far away so you can come the other one.
Oh.
Yeah, but maybe the other one, I'm not clicking.
Which we suggested. Keep an eye on it.
I will try this way, so maybe someone can.
I think we believe you.
Here it comes.
You getting a new call?
No.
Did you hang this up?
Yeah, Joe took care of that. Thank you, Joe. And over there on the right side, the screen that you see is Alberto's phone screen. So that is also live. His phone is actually streaming in here. So whatever you see there is him actually, whatever he's playing on the phone, you can actually see that over there. Yeah.
Yeah, please.
Well, you mentioned deploying 80 more beacons. So I haven't kept track, but is this a funded project now to deploy the beacons around the network?
Yes, it's fun.
Speaking there.
Yes, it is funded. And could you pop up the location for me? And
It's still in here, okay.
I think the other beacon must just gone.
It may have died.
It may have died.
Yeah.
I didn't. No, the rest of them are in store.
Okay, but I'm sorry, you were saying about the,
Yes, it is funded. It's T-Mobile generously gave us some funding for the project.
and do you have any users, like PSAP type users, or people who would come, first responders? Have they looked to see how they would feel about getting data like this versus what they get right now for location from the campus? How good it is to them. You've got your own test about
Yeah.
ABC. Have you asked anybody in the public safety world to evaluate what they think is good enough for right now? I know you want to get it best.
I did speak to Jerry Eisner. Can I? Yes.
Jerry?
Thank you. I did speak to him, and he did say that there is interest for something like this.
Okay. So this is, even if it's just down the hall, it's still a lot closer than what you would be getting if you tested the real 911 network from the same locations and tried to pick up the location
Yeah.
automatically.
The problem.
You gotta by room, there's must be some problem with that beacon, but
Well, I'm not critical. I'm just saying
Yeah.
the reality of today's network versus what you're doing here. Have you discussed, how much better this is than what the current campus public safety people get when they get a call from this same room on a real 911 call?
We have discussed with our school's public safety, and they are interested. They want to have some way to be able to find the people who have called into their network faster. We don't know. Again, I don't know how far I can push this because I'm just the developer. There's the whole layer of stuff that's not even in my power. But people have shown interest. People love this idea. It's just I don't know how far it will go before someone doesn't like it anymore.
I just thought, well, not doesn't like it, because I think commercially this is going to be the way of the future. But the interesting measurement would be comparing calls from the real network with permission to make those calls to what you're doing and showing how much improvement there is in location accuracy, so they could see it. That was just my suggestion.
One clear improvement is flexibility. So you have very small sensors. They are mobile, so you can put it wherever you want. If you have an emergency, or if you have a big event, for example, and you want to have a lot of precision, you only need to put more of those. Doesn't matter. If you have 4 in this room, if you get higher power and applying the correct algorithm, you can get a good chance of getting the right location. And if it's a big building, you can get into room resolution, which with other technologies maybe it's harder to achieve.
and for the tower, you got it down pretty much to the floor and the room number.
Yeah. And not just in the tower, even in Stewart Building, we plan to deploy about 20 beacons per floor. As of right now, we have deployed about 15, and accuracy is amazing. If you're standing in a room which has a beacon, that is the room that it's going to show when the PSAP call comes in. Again, we haven't tested this 100%. We're going to take Neil and we're going to start collecting test data and test the environment more rigorously. And when we do, we'll have much better solutions. Yes?
Maybe it's too early to assess it, but from the team's perspective, technically and commercially, which of the two approaches, Wi-Fi or Bluetooth, do you think has the brightest future?
My honest opinion, Bluetooth. It has...
From a cost-effective perspective.
Hmm?
We have to compare.
From a cost-effective perspective, yes, because these devices only cost, the Bluetooth beacon devices, they only cost about $2. And maybe the enclosure and some other stuff will cost you a little bit more, and batteries and stuff, but we're looking at less than $10 a piece if you can manufacture it.
The problem is the Wi-Fi system is not in your control. The Bluetooth is.
Yes.
Correct. So really the Wi-Fi is hopeless because you have to fight every different kind of Wi-Fi system in every building. Here, this is a custom system. It just goes in. You can put a sensor on the wall, and then you put in your algorithm computer servers, and then you're done.
Actually, the reason the Wi-Fi ordering thing is so awkward, instead of like doing say like a radius around every CP, is because we actually we weren't allowed to access quite a bit of the data. We weren't allowed to access most of the data we actually wanted to access. We got proxies.
And that's the real world.
Yeah. And so Bluetooth gives you total control, so it's a lot easier to work with, and it's cheap to manufacture, and yeah. But at the very least, Wi-Fi gives you, we can implement it immediately, just because the infrastructure is already available. So it's a short-term solution.
But the real world perspective is, right now, there's about 350 million Wi-Fi access points that are publicly known by their operators, including their location information, and there's less than 3 million Bluetooth points out. So it doesn't matter what they cost is, that when you're ready to deploy, having knowledge of a Wi-Fi network that's 100 times more dense, 100 times more data, has the value first, and it may take 10 years before buildings are deployed with smart infrastructure that includes Bluetooth beacons. And there's other issues about Bluetooth, like the identifier in Bluetooth actually rotates, according to the spec today, through I think 5 different identifiers. So as those rotate through, your database that has location has to take that into account. Industry's looking at creating a new public safety profile for Bluetooth, but that may be 3 years away before there's something static that we can use in a database to look stuff up.
Yeah, maybe this could be like, you could have 2 solutions used. Maybe you could use for the currently Wi-Fi architecture, and then if you have to deploy something extra, you can use Bluetooth, which is cheaper and could be added, or if it's something in the middle of nowhere and you don't have nothing there, you can use Bluetooth, which is easier. And if you have a current building with all the Wi-Fi infrastructure, you can use the Wi-Fi. Yeah, this could be an approach.
Realistically, new construction.
Exactly.
When standards say when you build a new building, just like you have to have sprinklers, will also say you have to have Bluetooth beacons, they have to be low power, they have to be every 3 feet. But there also needs to be a mechanism on a national level to accept that location data.
Yeah.
It's not going to be local.
No, I know, and the whole database, the management of it, there's room for so many papers, and you're already writing them associated with this, but I just think there's a great deal of knowledge to be shared. I think you're doing a marvelous job.
Yeah, we are carrying this off into the summer and into the next semesters, because there's many areas that have to be looked at. And I think in the green field, when nothing exists, then we can certainly, we'll put in Bluetooth first, probably. We found certain problems with the management system for the access points here, and there's not uniformity in how the access point management systems have been deployed in all these thousands of places. So there's going to be well, we're in the middle of a big development and an experimentation stage. So we have a lot more control over the Bluetooth that we have built ourselves, and the students spent a lot of time designing and building them. So they have control over them where we did not have control over the IT management systems here. So this is a great discussion, but I have to be the bad guy and call it off because we have other people on the agenda. So thanks everybody for questions.